So in this video, I'm going to talk about how to graph the tangent function. Now, I'm actually going to start by graphing the sine and the cosine curve, because one of the ways that we can talk about tangent is tangent, remember, if we equal it to, it can be sine of x divided by cosine of x. So that's actually what I'm going to base my graph off of, is taking the actual values of the sine function divided by the values of the cosine function. Now, I am going to color code this somewhat. First thing I'm going to do, though, is go through and label the x-axis. So I'm going to make this 2 pi. I'm going to make this pi over 2 and 3 pi over 2. That's the normal period of sine and cosine. I'm also, however, going to do the negative. So I'm just going to mirror these exact same values into the negative x-axis. So negative 2 pi. So my sine curve starts off at 0. It increases up to 1, back down to the midline, to its minimum, back to the midline. Now, if I continue this curve to the left, I would start from the origin. Now I can see this graph is coming down, so it's going to continue down to the middle. I'm sorry, not the middle. It was at the middle. It's going to continue to the minimum, bounce back up to the midline, and then curve over. So let's go ahead and do that. So down to its minimum, midline, maximum. All right, so there's a rough sketch of my sine curve, okay? So now I'm going to fill in the cosine curve, because again, I want to figure out how to find tangent and tangent here based off of sine and cosine. So I'm going to graph the cosine curve. So cosine generally starts off center high. So I'm going to start here at +1. It's going to curve down to the midline, down to its minimum, to the, let's see, came up short. There we go. Back to the midline and back to its maximum. I'm not quite making these curves, so hold on a second. I want to take this out and try and curve this just a little bit better. Okay. Let's do this. That looks better. All right, so I'm going to go ahead and continue the curve to the left. So it's already at its maximum point right here. So let's go ahead and curve back down to the midline, down to the minimum, up to the midline, and then back to its maximum. Okay. So we've talked about these two curves basically being the same curve shape, which close enough based off of my graph. Now, a couple things are going to happen here. I know that tangent is sine divided by cosine, and we have this pretty little table of values right here. So let's start at negative pi over 2. So negative pi over 2, I've got a sine value of -1 and a cosine value of 0. Unfortunately, dividing by 0 means that this is undefined. Okay, so anytime cosine has a value of 0, so anytime cosine touches the x-axis, all of those are going to be undefined values for tangent, okay? So we might have a bunch of them, but we'll have to see as we go across this graph. Now, this one is negative pi over 4. Now, I don't have negative pi over 4 as a critical value listed, but negative pi over 4 would be right here between negative pi over 2 and 0. Now, this one is a little bit difficult to tell, but mathematically, these 2 points, this point and this point, one is the positive value, root 2 over 2, and one is the negative value, root 2 over 2, which means if I were to divide those, and really it won't matter which one's which, but if I divide those, I'm going to get a value of -1. So tangent is equal to -1 at negative pi over 4. Now, what happens at 0? Well, sine is 0 and cosine's 1. So 0 divided by 1 is 0. At pi over 4, so again, I'm halfway between these. Now this one you actually really can tell. Those 2 points are the exact same thing. It's root 2 over 2 and root 2 over 2. So those values, if I were to divide them, would give me a tangent value of 1. And last but not least, I'm at pi over 2 here. Sine is 1. Awesome. Cosine is 0. 1 divided by 0, well, that's undefined. All right. So what does this mean for a graph for me? Well, I am going to draw in vertical asymptotes anywhere I have a tangent value that's undefined. Okay, so that's negative pi over 2 and positive pi over 2. And I'm going to go ahead and keep, I'll stay with the orange color here. No, actually I'm going to go kind of a bright green here. We'll see if that works. Okay, so at negative pi over 4, which would be right here, negative pi over 4, I have a tangent value of negative 1. At 0, I have a tangent value of 0. And at positive pi over 4, I have a tangent value of 1. Okay, so what's going to happen here is tangent's going to increase from 0 to the right, and from 0 to the left, it is going to decrease. So that's what the tangent curve, a single tangent curve, looks like. If we were to continue this, we would have another vertical asymptote right here because cosine is 0. So the tangent curve, grab a pen here. Here we go. So tangent curve would, again, curve up from the, I'm saying from the origin, but from that critical value at the pi value, it curves up and to the right and down and to the left. And if we wanted to do it one more time on the right side, nope, this is the left side. I know my left from my right, I swear. Except some days when I can't tell them. All right, so let's go ahead and graph that in. Now, what I am going to do, I'll leave it in the key, but temporarily I am going to take out the sine and the cosine curves. So you can just see those green lines, curves, are 3 cycles of the tangent function. Okay, now if you're asked to just graph a single period, then I just need one of these. Okay, one of these curves between the 2 asymptotes is perfectly fine. Okay, let's answer a few critical questions here. Amplitude. I hope you recognize that the amplitude here is not applicable. Okay, amplitude is defined again from the midline to the maximum. Because these graphs approach infinity, you don't have maximums. Okay, now this one's a little bit difficult to tell, a little bit, but not horribly difficult. The period is pi. If we look from 0 to pi over 2 on the right is half the graph, and then from 0 to negative pi over 2 on the left is the other half of the graph. So between these two is a total distance of pi units, so that is a period of pi. Okay, so that is these are the basic tangent graphs. Let's go ahead and do 2 quick questions with a few changes and see what happens. All right, so problem number 2. I'm going to go ahead and identify the pieces I would normally identify. Amplitude, period, phase shift, and vertical shift. Now, amplitude doesn't apply, all right? What we would have to pay attention to is if there was a number in front of tangent, it would stretch the graph further away from the x-axis, but that doesn't necessarily, it's not an amplitude change because amplitude just doesn't affect this graph, okay? Period, this is a normal tangent curve. There's nothing being multiplied times x here, so period is pi. Phase shift, we're going to go right pi over 2, and we have a vertical shift up 2. So I'm going to do what I would normally do with a graph. I'm going to graph it with the amplitude and period. Now, amplitude, again, is going to be a weird one here, but possibly a dilation or a stretch there. And then I will go through and do the phase shift and vertical shift. So the normal tangent curve, you have 2 critical units to the left, 2 critical units to the right. So it would be pi over 4, pi over 2. So it's basically do half the period, that's half the period to the right, and then chop it in half, and then you're going to do half the period to the left of the y-axis. So negative pi over 2 and negative pi over 4. So negative pi over 2 and positive pi over 2 would get your vertical asymptotes. And actually, I'm going to take those back, and I'm just going to put in 1 vertical asymptote there and there. Now, the reason I'm doing this is because eventually I'm going to have to shift this thing. And so I don't want to have a ton of asymptotes in there that are going to confuse me. Now, obviously, you can erase things later on. Totally up to you. All right. So what does the tangent curve normally look like? Well, it's an increasing function. So between your 2 asymptotes, you have 3 critical values. Negative pi over 4, 0, and positive pi over 4. So you're going to start negative 1, 0, positive 1. So negative 1, 0, positive 1. Okay. But all of this has to shift right pi over 2. So it's going to be right 2 spaces and up 2 spaces. Now, the vertical asymptotes really don't shift up because they're vertical lines, but everything will shift to the right pi over 2. So let's go ahead and do, I don't know, blue here, I guess. So I'm going to shift my 2 vertical asymptotes to the right 2 spaces. So here's one of them. And 1, 2, 3, here's the other one. Okay. And all of these little X marks the spots. I'm going to shift right 2 spaces and up 2 spaces. So right 2, up 2, right 2, up 2, right 2, up 2. And once you've got those 3 points in place, now it is a curve, so please don't draw a straight line through them. But it is a curve up and to the right and down and to the left. All right, so that's problem number 2. So that's 1 cycle of the tangent function. Problem number 3, let's see what we've got going on here for number 3. Amplitude, period, phase shift, and whoops, I don't know what I was just trying to write there. How about a vertical shift? All right, amplitude, none. Remember, that just doesn't apply to tangent and cotangent. I do, however, have a reflection. So I'm going to apparently spell that completely wrong, but I'm going to write reflect to remind myself of it. Period here is going to be the normal period divided by 1/4. So that's going to be a period of 4 pi. Phase shift, none, and vertical shift, none. Okay. So we are going to seriously stretch this tangent function side to side. All right, that's that period change. So I'm going to do half the period on the right side of the y-axis. So that's going to be 2 pi. Go half again, so that's going to be pi. And then mirror those 2 on the negative x-axis. So altogether between these 2, we have a total of 4 pi units. All right. So I'm going to go ahead and mark in my vertical asymptotes. Those are not moving left or right, so I don't have to worry about changing them. So now I'll go with the orange one. What I do want to pay attention to is there's a reflection. So instead of it going -1, 0, +1, I'm going to reverse it. +1, 0, -1. I've reflected those points over the x-axis. And once I have the 3 points in place, go ahead and graph it out. All right, so this is all about the tangent function. If you've got any questions or concerns, please let me know. Either through Zoom, through an email. Just ask your questions, make sure you understand